derivatives of other trig functions. All right, so now we can start finding the derivatives of the other trig ratios, so tan, cotan, etc. All right, so we can actually do this by breaking everything down in terms of sine and cos, right? So let's find these. So let's say if we had y is equal to tan x, we could rewrite that right off the bat as sine x over cos x. Well, now if we find the derivative of this, so y prime, this seems like this is the quotient rule, right? I'm dividing. So that would become cos x times cos x plus sine x times sine x all over cos squared x. Let's go back through that. Maybe make sure you guys saw what I did there. So if this was, you know, g times f prime minus f times g prime all over g squared. Okay, well, g was my cos. F prime was my derivative of sine, right, which is cos. And then f, which was, so this would have been minus to begin with, right? So this was f. And then g prime was negative sine, right? That's why this became a plus, because it was minus and negative, so plus. And then that was our g there. Okay, so hopefully you guys can see that. So now from there, well, what we have going on the top here, I've got cos times cos, that's cos squared, plus sine times sine, that's sine squared. So this is really cos squared plus sine squared. Well, that's one of our identities, which is 1. So this is 1 over cos squared x, otherwise known as secant squared x. So there you go. There's the derivative of tan is secant squared x. That is on your formula sheet, by the way, too. You won't have to do that every time, but yeah, so that's how we find that one. So now cotangent. So cotangent will be similar. So this would be y is equal to, now this would be cos over x instead, or cos x over sine x instead. So then that would become negative sine x times sine x minus, and then this would be cos x times cos x all over sine squared x. Now if you want to write out the rule or the quotient rule again and do and see if that makes sense, go for it, right? Okay, so then rewriting this would be, well, I'm going to factor out this negative right now. I'm going to do this in one step. So this would be negative, and then we'd have sine squared x plus cos squared x all over sine squared x. And again, sine squared x plus cos squared x, that's 1. So this becomes y prime is equal to negative 1 over sine squared x, which would also be known as negative cosecant squared x. All right, next one. So what's the derivative of cosecant x? So cosecant, so let's rewrite this as y is equal to 1 over sine x. And then one more time, I'm going to write this as sine x to the negative 1. Okay, so now if we take the derivative of this, it would be y prime is equal to, now chain rule, right? I'm going to bring down the negative 1 times, and then keep the inside the same, and then apply my derivative to the exponent here, just so minus 1, so that's negative 2 now. And then don't forget, we also have to take the derivative of the inside. Chain rule this out, so that would be times cos x. And that's pretty much it. So now let's just clean that up. So y prime is equal to negative cos x over sine squared x, right? I just applied that negative in the cos on the top, and then the sine x went down to the denominator. Okay, so there you go. It could be written that way. Or we could split this up a little bit too. We could write this a little different as negative cos x over one of these sine x's. So sine x times 1 over sine x. And then these are identities, so we can rewrite those as well. That would be negative cotan x times, I'm going to put these in brackets, times cosecant x. And there is our derivative. Okay, last one, so secant. So secant, we're going to rewrite this as y is equal to, I'm going to skip a step. This would be cos x to the negative 1. Okay, so then taking the derivative would be, so y prime would be negative cos x to the negative 2, and then times the derivative of the inside would be negative sine x. So y prime is sine x over cos squared x. So then splitting this up like we did in the last one would be sine x over cos x times 1 over cos x. So y prime would be equal to tan x times secant x. There, we have all of our derivatives. Okay, so let's kind of review what we have. So here's our derivatives. There's everything that we're going to need for doing these problems. Now, you guys do have this on your formula sheet too, right? You don't have to memorize those. So let's jump into it. So find the derivative of each of the following. Okay, so for this first one, we could do the quotient rule here if you wanted to, having 1 is f and then the bottom is g there. But you know what I prefer, just my preference I think, is to just rewrite this right off the bat as 1 plus cotan x to the power of negative 1, and then chain rule. I kind of like chain rule a bit better, but that's, like I said, might just be a personal preference. So let's derive this now. So I'm going to take this negative 1, bring it out front. So we've got negative 1, and then times the derivative of what I still had there. So 1 plus cotan x to the power of negative 2, and then the derivative of the inside. So the derivative of 1 is 0, so just leave that out. And then the derivative of cotangent, we know that now, that is negative cosecant squared x. So times negative cosecant squared x. And then just simplify this up. So I've got two negatives, so those will become positive. So in the numerator I have cosecant squared x. And in the denominator I have 1 plus cotan x squared. And then we're done. All right, next one. So right off the bat, I'm going to rewrite this again, just so we don't get confused by the placement of that 3 there. So let's write this as y is equal to 2, and then this would be the same thing as, like in brackets, cosecant of 3x squared, and then to the power of 3. Okay, you can use, if you want, right, if those brackets start to get confusing, you can use square brackets, so you can keep track of what you're doing there. So, all right, now we'll just take the derivative of this. So this looks like the job for the chain rule. Whoop. Come on, all right. So y prime is equal to, so bringing the 3 down, multiply by the 2, so that's 6. And then cosecant 3x squared to the power of 2 now. Okay, so first part of the chain, and then the second part, I need to multiply by the inside. So times, and then what was the derivative of cosecant again? So cosecant was that long one. That one. So negative cosecant x cotan x. negative cosecant x. Ooh, but it's not x, it's 3x squared, right? That is my x at this point. So I need to make sure I put that into these as well. So 3x squared, and then cotan 3x squared. And then it seems like you'd be done there, but we have one more to do, right? That was like the second step. We took the derivative of cosecant, and this was like my x in that case. But now we got to do the inside of that. Okay, so then the next part would be taking the derivative of 3x squared, which would just be 6x. And there you go, there's our derivative. Now we just need to clean it up. So cleaning it up, I'm going to look at any coefficients there. I've got 6, 6, and I do see there's a negative on that one. So let's put all of those together to call that negative 36. So now let's write this more like the original way, right? So it would be times cosecant squared 3x squared. I'll put that in brackets so I know that that's part of the cosecant, right? That's what's cosecant of that. Okay, and then move on to the next part. So now I'm looking at this one. So times cosecant of 3x squared. That's good. And then cotan. So then just writing it again. So then cotan 3x squared. And then we're pretty good, but I do notice that cosecant and cosecant, those are the same, right? So if we multiply those, you add the exponents. This is like to the power of 1. So just last part would be negative 36. Oh, I forgot the x, didn't I? 36x times, okay. So then minus 36x, and then combining these to be cosecant cubed, and then 3x squared, and then just times cotan. All right, so in this one looks a little scary actually, and maybe you see why. Well, actually the x, 3 of them. So you've got this x, and this x, right? We've got 3 that we have to deal with. That starts to become more difficult, doesn't it? So if I'm gonna product rule this, you know, it would turn out that like this would be my f, and this would be my g. But we can see that even when I take the derivative of f, I'm going to have to account for the product rule in that, right? I have like my own little f and my own little g I have to take care of there, right? So this becomes pretty complex. I don't like, you could do it, it'd be fine. It's going to get very long. It should all simplify to the right answer. But let's try breaking this one down into our just simple trig ratios, just sine and cos, and see if we can cancel something. So y is equal to x times, and this would be sine squared x over cos squared x times 1 over sine squared x. And hey, look at that. Sine squared x and sine squared x, they cancel. Oh, that becomes way easier, right? Now we don't got to deal with all that. Okay, so now this becomes y is equal to, and well, we could do it different ways. I could write this as x over cos squared x and take the derivative that way. But to tell you the truth, well, I could, like I definitely could, but we're just doing the other trig ratio. So let's write this as x times secant squared x and take the derivative of that using the product rule. So y prime. So this would be my f and my g. And you know, the g might be tough enough that you might want to just find the derivative of that on its own somewhere else. So the derivative of secant squared x, right? You could do it right in line if you want to, but you know, you can also write it over here first. So just be careful in these ones because this really is secant x squared. So we have to chain rule this. So this would be 2 times secant x. Okay, and then to the power of 1, so that's good. Just leave it like that. And then the derivative of the inside. So that would be secant x tan x. Okay, so there you go. So that's what that was. So let's start writing it out. I think we're good. So derivative of y. So that would be f times the derivative of g, which we just figured out there. So that was 2 secant x. And let's call it secant squared x right now, right? Because it's secant x times secant x. Just skip that step. Times tan x. And then plus, and now it's going to be the derivative of f times g. So that would just be 1 for the derivative of x, and then g is secant x, or secant squared x. Now, looking at this one, is there anything we can like combine? What can we do here? Well, I think all we can really do is look at the secant squared x's in both terms, and we can factor that out. So let's just do that last. So that would be secant squared x, and then you'd be left with 2x times tan x plus 1. All right, so in this one, looks like we got some y's and some x's. So I don't know if you guys are used to being scared of these ones or not yet, but this really means that we're doing implicit differentiation, okay? Which really isn't that bad, right? You just take the derivative like normal, but then we just have to remember to add on that y prime at the end. So we're taking the derivative with respect to x. So the derivative of tan would be secant. So this would be secant squared y, and then times y prime. Just chain ruling that out, right? Is equal to, and then the derivative of sine is cos. So it'd be cos x minus y. And then the derivative of the inside, okay, well, derivative of x is just 1. Derivative of y is 1, but then remember, so it's like 1 minus 1 times, and then we have to tack on that derivative of y. So that's a little awkward to write it that way. I think I'll just write it as y prime. All right, so now remember what we're after here. We want to get the y primes on the same side and then factor it out typically, and then divide by whatever's left, right? The other factor after we take it out. So right now it's just not really in the right form. I can't really bring this y over there. So really what I got to do is I got to expand this. So let's go 1 times that and then y prime times that to get 2 different terms happening. So this would be secant squared y and then times y prime is equal to, and then cos x minus y, and then minus y prime cos x minus y. All right, so that's looking better. So now let's get the terms with y prime in them over to the same side. So I'll bring this one over to the other side. So this would be secant squared y times y prime plus y prime cos x minus y is equal to, and then just what's left there, cos x minus y. Now let's factor out what's common, the y prime. So that you'd have y prime, and then what's left, just everything without the y prime. So then you'd have secant squared y plus cos x minus y is equal to cos x minus y. And then we'll just divide by all of this. So we'd have y prime is equal to cos x minus y all over secant squared y plus cos x minus y. And that's it. I think that's the fastest lesson we've had in 31.